All right, everything mathematics is back, and today we're here with order of operation, a part one of two videos, and also sad to say the part one, the penultimate video on the number theory. So yes, we're wrapping up number theory tomorrow, God's willing, with the part two of this video. Everything we did so far lead up to this order of operation on the number theory. What are we going to do today? Our objective for today is simple. We're going to just look at the concept of the order of operation, and then we're going to look at strategies to perform the order of operation. So let's look at the concept first. What is the concept really? I mean, sometimes we hear order of operation, you might hear order of arithmetics, you might hear arithmetic sequence, you might hear arithmetic order, but what is the whole gist of it? Let's get that at the top of our head first. So the big idea here is really simple. The big idea in order of operation is simply following a set sequence in performing the various computational operations. And really that's the bottom line. It's following a set sequence. So for example, if I tell you you have to add first and you have addition and subtraction in the same problem, the concept here is that you follow the sequence that you're following. So if I say add first, you see addition and subtraction, add first. I tell you multiply first, you see multiplication, addition, subtraction, multiply first. That's all you need to know when it comes to the order of operation. That's a big idea. Of course, in case we may not be clear on the same language here, computational operation simply speaks to adding, subtracting, multiplying, and dividing. That's what this whole thing is about. So don't get caught up with the language. So let's go straight into it. Strategies for performing order of operation. And one of my experiences, maybe let me not jump the gun. Let me keep it there still. Let's look at number one. So number one, we have BODMAS. And again, I emphasize, the order of operation is following a set sequence. The set sequence is dependent on the strategy that you choose. Not all the strategies have the same sequence, but all strategies should lead to the same answer. But in the event that it does not lead to the same answer, that's okay, as long as you followed your set sequence. I have seen cases where students use BODMAS and somebody else use BOMDAS and you end up with a different answer. So I know it is possible, but as long as you follow your set sequence, then your answer is right based on what you did. Sometimes it's something minor that gives the deviation. But again, that is why it's important to know the strategy and know which one you're doing. And I could tell you in advance, be careful with mixing them, because sometimes as simple as changing multiplication for division sometimes could make a big difference. Sometimes. So be cautious. So BODMAS, and what does BODMAS stand for? This is an acronym. So each letter here represents something. And BODMAS here is simply telling us this is a set sequence that we follow. So when we use BODMAS, we do bracket operations first. So you could label these as, if you ain't getting me here, label these like first. So this is first thing we do. This is the second thing we do, is a set sequence. Third thing we do, fourth and fifth. That's what we do. So if we have a question and all these operations are in play, the order that we follow is this. First, we do the bracket first. Secondly, we divide. If there is any division at all present, we divide. Thirdly, we multiply. Fourthly, we add. And last, if there is anything to do, we subtract. And as I said, if there is, sometimes you'll get a question and then we say there is no bracket. So if there is no bracket, then you look for division. If there is division, you divide first. So let me say there is division and there is addition. Don't go and add before you divide. You will get the wrong answer if we use in BODMAS. So be very cautious there. So that is all we do when we do order of operation. We simply follow a set sequence of operational, computational operation. So brackets first, then division, then multiplication, then addition, then subtraction. Let me go through the other strategies. Let me teach you the rest. There is 4 in all that I know. As far as I know, for all I know, there might be more outside it, but I know 4. So there is BODMAS, then there is BOMDAS. And notice when you look at BOMDAS, it's the same as BODMAS. However, multiplication goes before division, and that's very important to note. A simple thing like that could make a big difference when you're solving a problem. So, bracket of operation or bracket operation, that's BO, bracket operation. Then you have M, multiplication, D, division, A, addition, S, subtraction. So that's BOMDAS there for us. So if we choose BOMDAS, that's the set sequence that we follow. We do brackets first, then we multiply, then we divide, then we add, then we subtract. Then we go to PEMDAS, one that may not be too common, but from my experience, it's one of the best strategy because it covers a little more than what BOMDAS and BODMAS would do. What does PEMDAS do? Parentheses. So parentheses here is another word, is a fancier word for brackets. So in all, or in essence so far, they all three start with brackets. So brackets are very important. Never take for granted, whenever you get a mixed operation, never take for granted what's in brackets. Because all the rules here so far, the fourth one you will see is different. But all the rules here so far emphasize on brackets. So we have brackets, we have exponents. Exponent speaks about index, it speaks about power. So our exponent, for example, will be 3 squared. You see this little 2 here? That is what you call an exponent. Oh Lord, I feel lazy to write a whole word. So yeah, you get it point. So 3 squared, that's your exponent. So if you're solving a mixed operation and there's an exponent, according to PEMDAS, after you work out your parentheses, after you work out your bracket, your next highlight is any exponent that may exist in your question. Take note of that. Then, of course, we go to the regular routine. So after we handle our exponent, we have our multiplication, our division, our addition, and then our subtraction. Easy does it. Set sequence. And last but not least, we have IMDAS. IMDAS. And for IMDAS, all we say here is what? We have the index. So that's all we're worried about. If you have index, if you have any index, do that first. And then you do your basic operations in that set sequence here. Multiply, divide, add, subtract. And an index is the same thing as an exponent. So index and exponent is the same thing. I guess by the time we reach the index level, we already agree that brackets goes first. No question about it. Brackets goes first. In our next video, so this will be the end for today. In our next video, I want us to look at some various examples. So that's what we're going to do in the various examples. But again, being me, I just can't leave you hanging there. So we must do one, at least just one, so that we'll see how this whole thing does work. So supposing I have 4 plus, let's say 8, minus, and then I have a bracket there, 2 minus 7, close that, and then I have that divided by 3. Oh my, I hope this thing works out nice. What is this equal to? So my preferred, of course, as I usually tell students, choose a strategy. So I like PEMDAS. As I said, PEMDAS is the one that works best for me. I'm not telling you to stick to PEMDAS. You choose whichever one you want. So I use PEMDAS, and as I tell students, I write it first and then I follow the sequence. One of the mistakes a lot of students make, and I think that is why sometimes order of operation becomes difficult. We are of the belief that whenever you're solving a problem, we start at point A, which is 4 here, and we go to point Z, which will be our 3. And that is why I think a lot of students struggle, because they find it hard to go in between the question and solve something. But that's what you really need to master when you're dealing with order of operation. It's not about starting from 4 plus 8 and solve across. So maybe, and I don't blame them, because maybe that's how we thought from primary school come up. Maybe, I don't know, I'm not judging. But maybe we thought we start here and we go this way. But we have to be aware that no, in order of operation, that may not always work. Sometimes you might get lucky and yes, get the right answer, but not always. So I do parentheses first. Parentheses is bracket. So in a bracket here, I see I have 2 minus 7. So everything else remains the same. So I have 4 plus 8 minus, inside the bracket, I know that 2 minus 7 is minus 5. So I'll leave that there. And that's divided by 3. Good? So brackets is out of the way. Brackets, check. Is there any exponent? No, no exponent. So check. skip that. Multiplication. Well, not directly, but there is. There is this negative sign here multiplied by this negative sign here. So we could check that as multiplication. So 8 plus 4 plus 8, a minus times a minus would be positive 5 divided by 3. And that's equal to that, right? So yeah, let me call multiplication check. Then division. Yes, there is a division taking place here. We have 5 here divided by 3. So, like it or not, well, I will leave this as a fraction to make our life a little easier. So that will be 4 plus 8 plus 5 divided by 3. Let's leave it like that. This will make our life a lot easier. If not, you will end up with a fraction, and I don't want to work with fractions. Nah, I don't want to work with fractions. And after divide, so division taken care of, then we add. So what do we have to add? We have the 4 and the 8. So let me continue over here. So 4 plus 8, that will give us 12 plus 5 thirds. And we simply add this to fraction. Remember, this is 12 over 1. I like this. So remember, not too long, earlier in this week, we look at a simple strategy to make denominators the same, and this will work out perfect here. So the easiest way is to multiply this side here by 3. So I multiply the top by 3, and I multiply the bottom by 3. So that will leave me now with 36 over 3 plus 5 over 3. Easy does it. 33 over 3 and 5 over 3. And at the end of the day, when we add this, our final answer would be 41 over 3. I don't lie, my sincerest apologies. This worked out to be more complicated than what it is, but I hope you get the gist. I didn't expect it to end up with an answer so abstract. But that's what happens when you just make up random things. Right, and of course you could find a number that could go into 41. In this case, we know 13 is the closest. So 13 and 2 over 3. That would be our final answer. 13 times 3 is 39. 39 plus 2 is 41. And yes, that will be our answer. So in next video, part 2, we're going to be looking at strictly various examples, how we could perform this order of operation. I will be sticking to PEMDAS because that's what I like, that's what I do best. But you could use anyone. You could use BOMDAS, you could use BODMAS, you could use PEMDAS, or you could use IMDAS. The choice is yours, and more often than not, as I said, they all always end up with the same answer. On very rare occasions, you have different answers based on sometimes the order which you use. So again, like, share with your friends, subscribe if you haven't subscribed as yet, share it with others so that they'll be subscribers and we will grow our channel. Still looking to reach that 1,000 mark, which I know will take a while, but you can make it happen. Comment if you have any questions and turn on the notification so that you will always get these videos when they come out between Mondays to Fridays. So until then, see you tomorrow, God's willing, for our last video in this series and our last video in this week. You take care, and until then.